So this is the second graph chart derivative problem that I'm going to do, and this is from the 2017 test, and this is the last of the free response questions. This is problem number 6. I don't know if I've mentioned before, but problem number 1 and 2 are calculator questions, so I don't think I would expect those on this year's test because it is a little different. Problem number 3, 4, 5, 6 are no calculator questions, so this is possibly something that you might see. All right, so like I said, this is a graph chart, but they really want you to take a derivative type of problem. And the reason I call it that is because here we have a chart, here we have a graph, and the first thing they're going to talk about are derivatives probably. So let's go ahead and read through. Looks like we have g of x, and we also have g prime of x, so we know the value of g of x, and we also know the derivative. And then this is a completely different function. This is h, which looks like is a bunch of line segments. We know the value then, and we also know the slopes of these things. And of course, the first thing they do is introduce a different function. So we have g, h, and we also have f. Let f be a function defined by f of x equals, so we have the function f, we actually know what it is. Let g be a differentiable function. So we know we could take derivatives there. Right, so that means we could use all kinds of theorems. We also can take derivatives, obviously. The table above gives values of g and its derivative of g prime as select values of x. We already know that. By the way, this also means that it is continuous. Because it's differentiable, it implies that it's continuous. And it also says, let h be a function whose graph consists of 5 line segments, 1, 2, 3, 4, 5, and is shown in the figure above. Okay, so pretty standard. First question, find the slope of the line. Find the slope, right? We just need to find a slope. Find the slope of a line tangent to the graph of f at x equals pi. So we have f right here, and basically we just need to take the derivative of f, which seems fairly straightforward, and then we need to plug in x equals pi, which is slightly annoying, but that's okay. All right, so take the derivative. We just need to find the slope. We don't have to actually find the line that's tangent. So the derivative of f is going to be f prime is equal to, and here it looks like we're going to have a chain rule. Let me write down my sine, cosine, negative cosine. So the derivative of cosine is going to be, derivative of cosine is negative sine. So it's going to be negative 2 sine of 2x, right? Because we have a chain rule on that part, so that 2 comes out in front. We get negative sine. And then the next part is the derivative of e sine x is e sine x, and then we also have a chain rule on the sine x, which is cosine. Cosine x. And so probably the most difficult part of the problem is plugging in your pi without a unit circle. So we'll make a little custom one. So plug in a pi, and a pi there, right? And I'm going to draw a little unit circle right here, and we're plugging in, it looks like a 2 pi. 2 pi is going to be right around here, and pi is going to be right there. So the coordinate on this guy is going to be 1, 0. And the coordinate, if I went 1 unit left, would be negative 1, 0. So that'll give us our values, right? So what do we actually have here? Negative 2 times and sine of 2 pi. Sine of 2 pi is here, and sine is the second value, so that's going to be 0. That whole thing's gone, right? That guy's gone. Plus, and once again we're plugging in our pi right there. So we have e and sine pi, and pi is right over here, right? And sine is 0, so we have e to the sine pi is 0, which is going to be 1, times and cosine pi. Cosine pi is here, cosine is negative 1. So in the long run, we have 1 times negative 1, which is negative 1. Done, okay? All right, so next problem, B. Let k be a function defined by, and of course they introduce a new function because they want us to do some other type of differentiation. And this k value or k function is h with an f of x inside of it. So basically a chain rule type situation. And of course we have to plug in pi, so I'm going to use this unit circle type deal that I just created over here again. Okay? All right, so derivative of k is going to be the derivative k prime. And I am a little lazy with my notation here, but that's because I'm trying to make sure the videos don't go forever. Right, and here I have h, so the derivative of h is going to be h prime with an f of x plugged into it, and then times the derivative of the inside, which is going to be f prime of x, of course. Right? So now we just have to plug in our pi's into these things. So where to start? Looks like I'm going to start here. Plug in a pi, right? So f of pi, how do I find out what f of pi is? F of pi is this thing right here. So really it's going to be cosine 2 pi plus e to the sine pi. Plugging in pi, right? And pi got plugged in there and plugged in there. Once again, I'm using this little unit circle. So cosine 2 pi is going to be right back here in the first place. So it's going to be 1 plus e to the sine pi is over here, and sine is the second one, e to the 0. So that's going to equal 2. So really that guy right there is 2. And 2 now needs to be plugged into h prime, and h is this graph right here. So the 2 gets plugged in, and I'm finding this is a graph of h, so I need to find the slope at 2. So at 2, the slope is, and that's just a line segment, so the slope overall is down 1 over 3. So it's going to be k prime equals down 1 over 3. And then last part is I have to plug in pi into f prime, which I think is kind of unfair, because what that means is if I messed up on a, then I would be wrong, because I already did this work, right? F prime of pi gave me -1. -1 on a. So negative times negative is positive, and it's going to be 1/3. Okay? A lot of the problems aren't normally like that, where you have to use information from the previous one for the answer on the next one. Because if you get these wrong, even by a little bit, then they don't give you points for much of anything. Right? And we could talk about the point distribution on a different video, because each problem is worth 9 points. I think this year it may be 12 or something like that. All right, so C. Let m be the function defined by, so we have a new function, getting sick of these new functions, but a new function with g with a chain rule inside of it. I'm assuming, yeah, we're going to have to take a derivative here. So we have a function times another function. So we definitely have a product rule going on here. So the derivative of m is m prime equals the derivative of this part with that one written. So the derivative of g is going to be g prime with a -2x, and then the derivative of -2x is, let me slide it in there, -2, with times h of x sitting there, right? Derivative of this first part with the other one sitting there, and then plus the derivative of the second part, which is just h prime, times, and then this thing just sitting here, g of -2x. So now you just have to be really careful when you're plugging in 2. Because like I said, this is going to be worth points, what we have right here, but on the next step, if you just make one small mistake, then it ruins everything in terms of getting points on the test. So when I'm plugging in 2, I'm going to have m prime, and I'll be more official in my notation. So when I plug in 2, I'm going to get, and here I have two numbers, right? I have -2 times, take g, so I need to plug in a 2 right there. That's going to be really plugging in a -4. -4 is being plugged in. And I have a little chart on g prime of -4. -4 is right here, and the answer for g prime is -1. So that's going to be -1. And then the last one I need is h of x, which is really just h of 2. Right, that's what they're asking me to plug in. H of 2 is over here, and h of 2 is that actual value, right? That actual value is a fraction, and it was down 1 over 3, so that's going to be -2/3. -2/3. Okay, last couple things. We have to plug in 2 to this. So what's the slope at 2? at 2, the slope is, this is for h, right? S slope, okay, so we already have that slope. We said negative 1/3. And then times, now we have to plug in a 2 here also. So that's going to be g of negative 4. G of negative 4. G is over here, and negative 4 is there. G is 5 in this case, right? We're looking under that spot. G is 5. So how much did all this make? Like I said, we have 2 terms. That's a negative times a negative times a negative, which is negative something, negative some fraction. It looks like 2/3, 4/3, 4/3. And then here, and that's going to be minus 5/3. And we already have common denominators, thank goodness. So negative 9/3, oh, negative 3. Okay. All right, last one. Is there a number C? Just by the way they started this, this already makes me think they want me to either, to pretty much quote one of the theorems, intermediate value theorem, mean value theorem, something like that. On the closed interval from x is negative 5 to negative 3 such that, okay, so they're talking about slopes here. Is the instantaneous slope negative 4? Justify your answer. So I'm looking at G. Let me go up here to G. And I'm thinking negative 4, well, negative 4 isn't between those values, and negative 4 isn't between these values, so I don't necessarily want to look at the instantaneous slopes, because that's telling me no at this point. It's not guaranteed. Now let me look at these. That's a slope of 5, and that's a change of 5 and a change of 1. 5/1 is not going to help. This is a change of 3/1. I'm only looking in this section also, right? And this is a change of 8/2. Is that going to be 8/2? Is going to be 4? Is that positive 4 or negative 4? Let's find out right now. Okay, so I'm going to go 10 minus 2. Since I went in 10 minus 2, that means I also want to go negative 5 minus negative 3. That's going to be plus, sorry you couldn't see that I was plugging that in, but 10 minus 2, those are the y values, these are the x values, equals 8 minus negative 2. That's a slope of negative 4. So that's going to be a yes. Yes, and it's because of we just were talking about the slope, right? Since we're talking about the slope, yes, because the mean value theorem. And I am going to include a little bit more to say that I could actually talk about the mean value theorem, meaning because g of x is differentiable, right? We have to mention that we could talk about slopes there. There is a C in the interval. Okay, I'm going to box up yes and mean value theorem. Mean value theorem, differentiable. I think that would be sufficient since I did show this work over here as well. All right. All right, so the next one that I talk about for graph, chart, and derivative is going to be your responsibility. I'm going to give you some hints along the way, and hopefully you'll be able to have a chance on it, right? Because I know these problems are difficult.